5 days have passed since 3I Atlas's closest approach. Everyone expected a show. We got silence. But today, the first post-December 19 telescope data has arrived. And what we're seeing in that data isn't silence. It's the beginning of something new. The spiral keeps turning, and the next move has already been made.
December 19, the comet flew by. Nothing spectacular for the naked eye, but telescopes don't sleep. And here's what they've captured since the flyby. First, new images from Virtual Telescope Project and amateurs like Ivan Vasquez from Hawaii. On frames from December 21 to 23, the comet is fading, but its tail has radically changed. A second ion tail appeared, thin, blue, directed almost perpendicular to the main dust tail. This isn't standard. Ion tails should follow the solar wind like a flag. Here, as if a new exhaust channel opened inside the nucleus right after passing Earth.
Second, data from Parker's solar probe processed only this week. It observed the comet from October to November, but post-perihelion images show the hotspot inside the nucleus didn't cool. It heated up by 18 degrees. Flashes became more regular, matching our old friend, the 4.132-second periodicity. Third, China's U-2 rover. On December 20 and 21, it caught a short signal at 8.42 gigahertz. Not long like in summer, just 7 seconds, but new modulation, a sequence resembling coordinates in the Kuiper belt, where calculations suggest the next object on hyperbolic path might hide.
This isn't coincidence. This is a chain reaction. The deepest implications come when we connect this fresh data to the von Neumann Bracelet theory. The comet didn't just fly by, it completed a cycle, collected info about our system, transmitted the report via the second tail as an antenna, boosted the internal source for the final pulse, the lunar signal delivery confirmation. It activated after the close Earth pass, as if finishing a scan task.
And now the most intriguing part. The next step is already scheduled. In just over 2 months, in March 2026, 3I Atlas will encounter Jupiter. Not a collision, a gravitational flyby at about 0.8 AU. But in the von Neumann Bracelet theory, this is no accident. Jupiter is a giant with the strongest magnetic field and moon system, the perfect amplifier for any signal. If replicators are truly working inside the comet, the Jupiter flyby could use its magnetosphere as a massive antenna for long-range transmission toward Lyra to WDJ 1917 plus 7354. In that moment, a powerful pulse will detect from Juno or from the upcoming Europa Clipper mission en route. This could be the final report on us before the comet leaves the system forever. Or the activation of the next experiment phase. Replicators use Jupiter's magnetosphere to infect its moons, Europa, Ganymede, with copies, creating a backup base in our system. Jupiter's Hill radius, the boundary of its gravitational dominance, is approximately 50 to 53.5 million kilometers, about 0.34-0.35 AU, a vast region allowing it to capture many moons and asteroids. The hyperbolic trajectory from interstellar space has been adjusted by the Sun and planet's gravity with accuracy down to thousands of kilometers. Wow! A gravitational flyby at about 53.6 million kilometers, 0.358 AU. The comet will pass exactly in the zone where Jupiter's magnetic field, the strongest in the solar system, can interact with its plasma. This can't be random. But such perfection,
53.56 plus or minus 0.45 million kilometers looks too precise for a natural object.
The trajectory's precision, 0.003 AU error, makes it suspicious. In astronomy, such ideal flybys are rare for interstellar objects. It's as if the comet knew where to go.
As if the von Neumann replicators calculated it in advance to use Jupiter as a giant signal amplifier. The giant planet's magnetic field, thousands of times stronger than Earth's, captures the tail plasma. The second perpendicular ion tail we're seeing now could become a directed beam, an antenna
for transmitting data toward Lyra.
The hotspot inside the nucleus heats up even more, using Jupiter's radiation belts as an energy source. If the replicators are active, the Jupiter flyby is the ideal moment for going loud on a galactic scale. We'll see it in Juno data, magnetic field spikes, anomalous radio waves. Or in Earth observations, a sudden whisper from the comet amplified by Jupiter.
We thought December 19 would be the peak. It was just a trigger for the next act, the encounter with the gas giant. From Shklovsky's whispering comets to von Neumann bracelets, our path led here. Science says unusual but natural comet. But post-December 19 data, with this suspiciously precise trajectory to Jupiter, shifts the emphasis.
Let's calculate the probability. An interstellar object enters the solar system on a hyperbolic trajectory. The chance that it passes exactly in the zone of maximum interaction with Jupiter's magnetic field is less than 1%. And if we factor in that the trajectory also brought it close to Earth during our technological peak, the probability drops to astronomically small values. It's like a rock thrown from another galaxy hitting the keyhole on your front door. By accident? Or did someone calculate this trajectory long ago, knowing where Jupiter would be billions of years later?
What we can do today while the comet is heading toward Jupiter. First, observe. The Juno probe is still orbiting Jupiter. Its instruments are tuned to the magnetosphere and radio waves. NASA could reorient it to monitor the comet in March 2026. Second, listen. Radio telescopes like Allen, FAST, Meerkat could be pointed at the comet during the flyby to catch any amplified signal. Third, prepare for long-term consequences. If the von Neumann bracelet theory is correct, the replicators could use the gravitational flyby past Jupiter not only to transmit a signal, but also to disperse some of their copies into its system. For example, microscopic structures could be ejected toward Europa or Ganymede, moons with subsurface oceans and magnetic fields, perfect for hibernation. There they would wait not for a signal from Earth, but for the next suitable trigger. For example, a powerful radio burst from our civilization, a new technological leap, or the passage of another bracelet through the Jupiter system decades later. Then missions like Europa Clipper, arrival in 2030, or future landers could discover not only signs of life, but anomalous nanostructures, traces of ancient technology that we might initially mistake for natural minerals or organics. We are not passive observers. We can become active participants in the experiment, redirect probes, intensify observations, even send our own signal toward the comet to test if it responds.
Jupiter isn't just a planet, it's a gateway. Magnetic, gravitational, energetic. If the von Neumann bracelet uses it as an amplifier, then in March 2026, we might hear not a whisper, but a loud voice from another star system. Or see the comet leave seeds on Jupiter's moons, a backup copy for the next cycle. The trajectory's precision suggests this isn't the end of the comet's journey. This is its culmination in our system.
The universe is vast, its mysteries endless, but the spiral turns on.